which is the cumulative frequency diagrams, shows information about the distance d kilometer traveled by each of 60 male cyclists in one weekend. Now, this is the cumulative frequency curve. Curve is given. What we have to do is use the cumulative frequency diagram to find an estimate of the median. We need to find an estimate of the median. Now, what is median? For median, we know as the last cumulative frequency is 60, or you can say the total frequency is 60. Always last cumulative frequency will be equal to total frequency. So, which is 60. For median, what I need to do is I will take 60 over 2, which is 30. It means the 30th value will be median. So from cumulative frequency, from this 30, what should I do? I will draw the line till the graph. From here till this one. Now what is this value? For that you need to look at the scale of the given graph. If you look horizontally from 0 till 20, there are 10 boxes. It means horizontally each box is, one box is equal to 2 kilometer. In the same way, vertically you can say between 0 to 10, there are 10 boxes. So it means I can say vertically each box, one box is equal to 1. So on that basis, if I will see, this is uh, 50 and 52. So this one is 52 kilometers. So I can say the median is 52 kilometers. And then in the second part, we have to find the lower quartile. Lower quartile, which is represented by Q1. We know it is quarter of the total total frequency, means 60 over 4, which is 15th. So the 15th value. So from the cumulative frequency curve, where is 15? This is 15 here. From 15, I will draw the line till this curve. That is. So I can say this is 30, 32, 34, and 36. So Q1 low quartile is 36 kilometer. And then we need to find the interquartile range. Interquartile range IQR, which is Q3 minus Q1. So I need to find Q3 also. Now what is Q3? We know Q3 is 3/4 of the total frequency. So 3/4 of the total frequency, that will be, if I will calculate, 45. So from the cumulative frequency curve, where is 45? This is 45. Draw the line. So this one, which is 62. So 62 kilometers is Q3. So I can say 62 minus 36. So 62 minus 36, if I will take, that is 26. So 26 kilometer is interquartile range. We found the interquartile range of this one also. Okay, after that, now the next one is part B. For the same weekend, the interquartile range for the distances traveled by a group of female cyclists is 40 kilometers. This is the interquartile range for the female cyclists, which is 40 kilometers. Make one comment comparing the distribution of the distances traveled by the male with distribution of the distances traveled by the female. We have to compare them on the basis of interquartile range. Now, this curve is for the male, and we right now we found that interquartile range for this one is 26. If the data is chosen for the female cyclist, their interquartile range is 40 kilometer. This is for the female, and for the male we found interquartile range. I'm just writing this here so it will be easy for me, otherwise I need to go back each time. So for the male is 26 kilometer. We have to make one comment comparing the distribution of the distances traveled by the male with the distribution of the distances traveled by the female. Okay, comparing this one, we can say the interquartile range of the female data is more, because this interquartile range is more, is 40 kilometer, and the interquartile range of the uh, male is 26 kilometer. So it means I can say if interquartile range of females is more than interquartile range of males. It means the spread of data for the females is more as compared to the spread of data for the males. Because when we take the interquartile range, so I can say the spread of data for female is more, because interquartile range will let us know about the spread of data. Or you can say this one also, you can say the female data has more variety. Okay, the female data is more varied. So number C is a male cyclist is chosen at random. We are selecting it at random. Find the probability that he traveled more than 50 kilometers. Now come to the cumulative curve again. We selected from more than 50. Where is more than 50? Here is, let me change the color so will be more visible to you. This is 50. 50 kilometer. This is for the 50 kilometer. So one of the menu selecting we are choosing from more than 50. For more than 50 is here. All right. So now what this value is, this is 30, 29, 28, 27. This is 27. It means all these are traveling less than 50 kilometers, and above this all are traveling more than 50 kilometers. So we are having total 60. Out of these 60, how many are traveling more than 50 kilometers? Are 60 minus 27. So if I will take 60 minus 27, it's 33. So it means 33 out of total 60. So that will be the probability, or you can write it in the simplest form. 33 divided by 60 in the lowest form will be 11 over 20. So I can say 11 over 20. Now part D is use the cumulative frequency diagram to complete this frequency table. Now we have to complete the frequency table. From 0 to 40, it is given the number of the male cyclists are 18. From 40 to 50 are 9. From 50 to 60, we have to check how many are there. From 50 to 60, let's see. This is 50. We know that for the 50 are 27, yes. For the 60, if I will check for the 60, let's draw the line for the 60. This is 60. So how many are for the 60? For the 60 are these 40. So it means how many are from 50 till 60? How many are 13? So I will say are 13. So here it will be 13. Now from 60 till 70. From 60 till 70. Now from 60, this is 60, and here I will draw for the 70 also. This is the line for the 70. Yes, here it is. Here is our. So how many are from 50 till, sorry, from 60 till 70? 60 was 40, and for 70 are how many? This is 50, 51, 52, 53. So this is 53. So total are again 13 for this one. Now from 70 till 90. From 70 till 90. This is 70, and where is 90? This one is 90. So draw the line from here. From 90, if I will take, yeah, so how many are for 90? This is 55, 56, 57, 58. So this one is 58. It means, so how many are total? 5 between them, yes? So I would say 5. Here this is 5. And adding all of them, you will see you will get 60. If you don't get 60, it means you make mistake somewhere. That will give you 60. The next part 2 is calculate an estimate of the mean distance traveled. We have to calculate the mean distance traveled. Now this is all frequency. These are frequencies, and here we have. So first I need to get the middle value for these also. So let's get the middle value for each one of them. If I will take the middle value of this one, let's make the table is better to find the mean always. First write the table here. How many I have? 1, 2, 3, 4, 5, 6. The data is distributed into 6 groups. So I will write here. I'll make a table with 6. One second. It's better if I will draw. Oh, sorry. If I will insert a table, that will be more better. Just one second. Let me insert a table of 1, 2, 3, 4, 5, 6. So with the 6 rows, 6 instead of 7. And from this table, let me say here, this is my table that I will use to find the mean. Here I will write x, the middle value. Here I will write f, and here I will write fx. Now what is x? X in this case is the midpoint of this one. For each one, x is the midpoint, okay? So how do we take the midpoint? The lower class boundary, upper class boundary we add, means 0 plus 40 over 2. So that will be 20. In the same way, 40 plus 50 divided by 2 is 45. Same way for 50 plus 60 divided by 2, 110 divided by 2 is 55. So I will say it's 55. Then 60 plus 70 divided by 2, 60 plus 70 divided by 2 is 65. This is 65. And then 70 plus 90 divided by 2, is 80, and then 90 plus 120 divided by 2 is 105. Now their frequencies, respective frequencies, if I will write 18, 9, 13, 13, 5 and 2. So let's find fx for each group. So the first one is 18 times 20, which is 360. 45 times 9, I'll take 45 times 9, that is 405. 55 times 13 is 715. 65 times 13 is 845. 80 times 5, which is 400, and 105 times 2, which is 210. Now I know the sigma f, the sum of all the frequencies is 60. Sigma fx I need. For sigma fx, I will add all these fx, 360 plus 405 plus 715 plus 845 plus 400 and plus 210. That is 2935. So mean will be sigma fx over sigma f. So sigma fx is 2935 divided by 60. So their average will be, if I will divide it by 60, that will give me 48.916, which I can say to three significant figure will be 48.9. So that is the mean of this one. Okay. Now next question number 6. Circle theorem we have to use in this case. In the diagram, A, B and C and D lie on the circle with center O. This is the center of the circle. So obviously OA and OC are the radius of the circle. Angle ADC is 128 degree and angle ACD is 28 degree and angle BCO is 30 degree. So show that the obtuse angle AOC is 104 degree. Give a reason for each step of your working. We must have to give the reason for each step of our working. Now, right now, I know that the angle at the center, the angle at the center is double of the angle on the circumference. So, but within the same, if we take the same sector. So right now, if I will take this chord AC, looking at this chord AC, we can say that if this is chord AC, this chord AC is making an angle of 128 degree here. But this one is on the other side. So I can say, if I have to consider this obtuse angle, so in that case, if I will consider this angle will be the double of this angle. Mean this angle, if I will take, it is going to be, I can say 128 times 2. 256. This angle is 256. Because if they will be on the same side, like let's have a look at this one. If this is the chord within the same. So right now, this one is 256. So what this angle then will be? From total 360, I will minus, so I will get it 104 degree. So for that reason I can mention, because we have to mention the reason for the each step of our working. So I can say in the reasons, first of all, This one, in this case, let me say, is, yeah, this is 128, and this is 104. So I can say angle at the center is double than angle on the circumference. So now, finally, this AOC will be equal to 360 minus 256, which is 104. I think we did this question in some other paper also. I don't remember exactly, but it was resembling with this one. Part 2 is find the angle BAO. We have to find the angle BAO. This angle BAO. We need to find this angle. Now, to find this angle, what I need to do is, first of all, I know this is 30. Somehow, if I try to manage uh, this one, take this triangle, consider this triangle OAC. We know this angle is 104. So then this one is radius, this one is radius. So this is an isosceles triangle. For isosceles triangle, it means this angle and this angle both will be same. If this is x, this will also be x. So I can say this x plus 104 will be equal to 180 degree. So 2x will be 180 minus 104. So x is going to be 180 minus 104 divided by 2. So that will be 180 minus 104 divided by 2. So it's 38. It means this angle is 38 and this angle is also 38. Now, to find this one, I should also consider this triangle. Let's find this angle also, because we need to find this angle too. If I will consider this triangle, I'm not going to that space because otherwise every time I need to come back to this one. So consider we are doing this one part B, okay? And these are the part of the part B, this one, and even including this one. Now, if I will consider this triangle, let's say consider this triangle A, C, and D. This is 128. This is 28. So what this angle will be? In that case, if I will say this is y, so what y should be 180 minus other two angles, 128 minus 28. So let's take this 180 minus 128 minus 28. So that is 24. So it means this angle is 24. Now, if you consider the cyclic quadrilateral, let's consider this whole cyclic quadrilateral, because this A, B, C, and D is the cyclic quadrilateral. And the sum of angles of the cyclic quadrilateral opposite angles should be 180. It means this total plus this total must be 180 degree. Let's suppose if I say this angle as Z. So what Z should be? Z should be from this one. This is 28, 38 plus 30 plus 24 plus 38. From 180 you have to minus. So that will be remaining in that case. So you can say, I will write it. Finally, I can say this Z, which is this angle BAO. I will say BAO equals to, because some of the opposite angles for the cyclic quadrilateral should be 180. So these red marked angles should be 180. So I can say the remaining one will be 180 minus this 28 plus 38. Let me count them here once. 28 plus 38 plus 30 plus 24 plus 38. That's 158. So you should subtract.
Then it's 128.
Oh, let me recount. Let me recount. 28 plus 38 plus 30 plus 24 plus 38. It's 158. So this one is 158. So it means it will be 158 minus 180. So 22. It means this angle is 22 degree. And now for the part 3, find the angle ABD. We have to find the angle ABD. Where is angle ABD? This one. ABD. This angle we need to find. Now we know that this one is also 22. Here I will just replace it with 22 degree. Now we have this one. Somehow if I manage to find this angle only, then I can do easily. Let's say I will say this one, this point P. So if I consider this triangle APD, this is APD. This is a triangle APD. This one is 90 degree obviously, and this one, this angle is 24. So then what this angle will be? Because we know this total is 128, but out of that we need this angle. So this will be 180 minus 90 minus 24. So if I will calculate it, 180 minus 90 minus 24. So that is 66. So this one is going to be 66. Now consider this triangle ABD. If I will take this is 66. Consider the triangle ABD. In the whole triangle ABD, it will look like this one. And now I can say 180, the required angle ABD will be 180 minus this plus all these angles. Let's first count all of these. 22 plus 38 plus 24 and plus 66. So these angle, including this one and this one, they are making in total 150. So from 150, if I will, let me check again. I did somewhere mistake, I think. Let me recheck. That was, if I consider 90, 24, 180 minus 90 minus 24, and that's 66. 66 plus 24 plus 38 plus 32, 160. So this is 160 minus from 180. So the remaining will be just 20. So this is going to be 20 in that case. But looking somewhere I make mistake. I don't know where. I need to recheck it. But I think you can check the calculation if there is somewhere calculation mistake. The method will be same. Part 4 is the radius OC of the circle is 9.6 centimeters. Calculate the total perimeter of the sector OADC. Which sector OADC? This one is OADC. This sector I have to consider. It is like this one. This is OA. Here if I say D and C. So we know this angle is 104. For sector what we need? If this radius is given also, this radius is given 9.6. Central angle is 104. So what will be the perimeter? For perimeter, I need to get this arc AC. So first of all, arc AC, the length of arc AC, let's suppose is L. What will be the length of arc AC? Theta over 360 into 2 pi r, which will be 104 over 360 times 2 times 3.142 times 9.6. That is L. So total perimeter if I have to take for the sector, how do we take the perimeter of the sector? radius, the perimeter will be equal to this radius. This is 9.6, 9.6. This is 104, and this one I consider as L. So it will be L plus 2R. So L is this one, 104 over 360 times 2 times 3.142 and time 9.6 plus 2 times 9.6. So just calculate this one. Let's calculate. It's 104 over 360 multiplied with 2 times 3.142 times 9.6 and plus 2 times 9.6. That is 36.62. So you can say 36.62, which by rounding will become 36.6. Now part B is these are two shapes and are mathematically similar. Whenever the word mathematically similar comes, immediately what should come in your mind? The ratio of volumes, V1 over V2 will be equal to L1 over L2 cube. Ratio of area, A1 over A2 will be L1 over L2 square. So, and if you compare between volume and area, this one will be A1 over A2. If you compare them, so you can say A1 over A2 can be equal to V1 over V2. Let me, if I will say L1 over L2 from here, L1 over L2 will become square root of A1 over A2. And if I will put it here, so I can say V1 over V2 will be equal to power 3 over 2, or A1 over A2 formula can be V1 over V2 to the power 2 over 3. So these rules will be for the similarity wherever you need to use. Now question is saying the volume of the smaller prism is 648 centimeter cube. I mean, you can say this is V1 and V2 is for this one. And the volume of the larger prism is this one. I mean, V2 is 2187 and V1 is 648. The area of the cross section of the smaller prism is 36. Mean A1 is given 36 centimeter square. We have to find the area of the larger prism. So use this rule. A1 over A2, we can write it A1 over A2 will be equal to V1 over V2 to the power 2 over 3. So if you need to find A2, what A2 will be equal to A1 times V2 over V1 to the power 2 over 3. That will become. So just put the values now. A1 is 36 times V2. V2 is 2187 over V1 is 648 to the power 2 over 3. Okay, just let's calculate it. 36 times 2187, this is 87, sorry, not 81, divided by 648 power 2 over 3. So will give me 81. So that area is 81 centimeter square. Now next is the larger prism is melted down into a sphere. Calculate the radius of the sphere. This larger prism is melted down and is shifted into a sphere. Calculate the radius of the sphere when the formula for the volume of the sphere is this one. Now it means what is the volume of the larger prism? 2187. It has been melted and make the sphere. Now in place of volume write it 4 over 3 pi r cube is equal to 2187. From here I need to get r, the radius. So what will be, I can say r cube will be equal to 2187. This 3 when I will shift to the other side will multiply over 4 pi. And if I will take the cube root on both sides, so r will be, now let's calculate this cube root value. Cube root of 2187 times 3 divided by 4 pi, 8.05. Radius will be 8.05. Okay,